have 3 lines equations wise. Point slope is one of them. That is true. And do you know the equation for point slope? Yeah, that's right. There. That's one of them. Point slope. Then we have, what are the other 2? Yeah, they're standing, they're screaming at you, right? We have slope-intercept. Slope-intercept. Microwave x plus b. And then we have standard form. So those are our 3 linear forms. Bless you. And we can, bless you. And we can graph each of those linear forms. We could, each of them kind of give me something different. Like a standard form, I can quickly find my x and y intercepts because I cover up y and find x, I cover up x and find y. It also can tell me, well, yeah, we'll leave it at that. In the slope-intercept form, I know where I'm crossing the y-axis because I have b, which is called the vertical intercept. And then I know what my slope is, which is telling me how I move from one point to the next on the line. Slope is rise over run. And then point slope form, its advantage is I have slope, and I can do a graph from any point. Slope intercept and point slope are very much the same thing, except with point slope you have x1, y1 as this point, whereas in slope intercept you have the vertical intercept as a point, and then from there you move to be able to graph these things. All right, so this is all of the stuff that we've been working with through Algebra 2 with regards to lines. And we have horizontal lines, right? Vertical lines, parallel lines, perpendicular lines. The 2 get confused often. These 2 do. These 2 get confused with their equations. Because we think about horizontal lines, we think a horizontal line, horizontal thing is an x-axis. That's true. But the equation for horizontal lines go through the y-axis, so they have y equals. And then a vertical line, you think, oh, vertical is the y-axis. But a vertical line goes through the x-axis, therefore it has to have an equation x equals something. So those 2 equations get mixed up. The slopes of those, think horizontals with vertical slopes. If you guys are skiers and snowboarders, do you go off of a cliff, right? If you go off of a cliff, there is no slope, it's undefined. That's the fun one. That's the fun way to ski. Or if you stay on the slope bunny trails where there is no slope, you have to keep pushing yourself the whole time because you're not going anywhere. So slopes of horizontal lines are zippo, nada. Going off the cliff, undefined, fun stuff. All right, so that's all the info that we've been working with for our lines. Now, this is a kind of a funny thing. This is entitled 3-2 straight lines. Aren't lines straight? It's kind of a dumb name, don't you think? All lines are straight. If you don't have a line that's straight, it's a curve. It's not a line. Look at these people. All right. So here's our slope equation. Rise over run, y2 minus y1, y1 minus y2 is against the order, doesn't matter. We can think of it about this again. Change in y, change in x. And then here's what they look like. If you're going left to right on the graph, you go left to right on the graph. If you walk up the hill, you're going on a positive slope. If you walk, you're not moving up or down the hill. You have 0 slope, right? Go back to our skiing example. If we're working left to right and we're walking down the hill, you have a negative slope. And then if you jump off the cliff, you have undefined slope. Only make sure you have a parachute on prior to doing it. And it gets exciting. Review, review, review. Right? Nothing new in this stuff. Now, here's the only thing that we're going to have to be careful with when we write our standard form. Yeah, standard form, the AX, the BY, the C. When we write it, we're going to write it where A is a whole number, no negatives, no fractions. B and C we will use as integers, so they can't be fractions, but they can be negative numbers. So sometimes we're going to have to tweak this equation to make it look like this. It might not end up with an A and a B and a C that are whole numbers or integers, but I can adjust the equation to make that happen. All right. Real quick, do we need to go over this, honestly?
No.
Thank you. Unless somebody wants to. Do we need to go over finding the slope of the line? I probably shouldn't have said it like that. All right, so slope of the line. Okay, looking at, here, let's just do this real quick. Quickly tell me, without doing any calculations, can you know what the slope of that equation is? Or that line? Do you know? Do you know? Do you know? What is it? 0, how come? Good. Look at your y values. They're the same thing. When your y values are the same thing, that means your line is horizontal. It means you have a 0 slope. Yeah. Do we have any vertical lines up here? Any of these 4 examples vertical lines? Which one? That one. The bottom one, yeah. This is a vertical line. How come? Because the x values are the same. So you can say x minus x, 2 minus 2, you get a 0 on the bottom side of the line. So finding slopes of a line, simply finding x1, x2, y1, y2. Plugging in and going. Let's move. Let's get to the writing equations part. This is the part that we've been, again, hammering. It's algebra 1. How do we write equations of lines? I want to be able to go into all 3 forms. So we want to go slope-intercept form, we want to go standard form, we want to go point-slope form. Now I call one of those my gatekeeper, which is the form that you can start in, and then transform it to the other 2 forms. And so I use point-slope form as my gatekeeper. You can also do slope-intercept. So there are a couple different ways to write equations of lines given some points. But what you need to do is realize the name of the equation tells you what you have to write that equation. So a point slope means I need to have a point and a slope to be able to write the equation. A slope intercept means I need to have a slope, and then specifically the point is a vertical intercept. And the standard form is really kind of the only one that's named in such a way that it doesn't tell me what I need. So don't have any tricks on standard form. But we can get to standard form from either of these 2, from either slope intercept or point slope. All right, so let's see, point slope form for these, we've got 2, 3, 5, 9er. What do I need to find first? Slope, we're going to find that real quick. We're going to find the slope between them. Change in y. Change in x. Change in y. 9 minus 3. 5 minus 2. 6 over 3. 2. Slope. Now we know slope. So in order to use point slope form, I need to pick a point. And I have 2 to pick from. It won't matter which one I use. I can have 2 different answers if I say write the equation of point slope form. Because I have either 2, 3, or I have 5, 9. So we're going to use 2, 3. Start out with the generic. Plug everything in. Now, what do I not plug something in for? There are 2 things I don't plug something in for. First y and the first x. Yeah. So the x1s and y1s, those guys, these are the coordinates that I'm plugging in. So there's my x1, and here's my y1 that I'm plugging in. But the other ones I'm going to leave alone. All right, so we go y minus a3 is equal to a 2 times x minus a2. And now you're in point slope form. That's it. That's point slope form. If I wanted to take that further, which we're going to do here with this next one, I have to do some distribution and moving. So there are only 2 steps to take me from point slope to slope intercept. distribute and then move the constant that's with the y on the other side. Now there could have been another, I told you there could have been another equation for this. We could have used 5 times and had y minus 9 is equal to 2 times x minus 5. Now those two are both point slopes, but you can see that they look different obviously. But they're both right. If I just said, hey, let's give me a point slope, you give me one of those two, you're good. So now this is where they start to funnel and become one. If I now take both of them and I rewrite them into slope-intercept form, I'm going to get the same looking thing. So let's, there's that one. There's that one. So we distribute, so we go 2 steps. We distribute. Slope-intercept form. So if you did that over here, y minus 3, 2x minus 4, that's the distribution part. Now we move. We get y equals 2x minus 1. If I did that on the black equation, y minus 9, 2x minus 10, move to 9. Look at that! What is that? So then we'd be in slope-intercept. Then to go to standard form, well, our standard form, we have maybe 2 steps. 2 steps to go from standard form, slope-intercept to standard. So, remembering standard form must be this in such a way that A is a whole number, B is an integer, C is an integer. I have to be careful if I just subtract the 2x, which is the first thing we do. Move x term with y. So subtract that over here. Negative 2x plus y equals negative 1. Yes, that is in the x, y, c, ax, by, c. But we want this to be whole, and it's not. So we need to change this. And it's a simple thing. We just say, I got to divide that by a negative 1. Divided everything by a negative 1. Then I'd be whole number, integer number, whole number. Now you're in standard. 2x minus 1. So you will see that there are sometimes problems that show up, even in this text, I think. Sometimes there will be problems where there'll be x's and y's on the same side, but they might not be whole number, integer, integer. It's okay. You can still just manipulate them and change them to make them look like this. The reason we're doing this is when we move to honors, this is what we write all of our linear equations into. You're not moving on. Come on, that's where the fun begins. That's where the fun, that's where it's exciting. So we write most of our linear equations in this form, so that's why we're doing this. We're trying to get ourselves into a good habit of writing stuff. All right, that's our down and dirty quick review of going from one form to the next, just knowing 2 points. How would this change if I knew 1 point and a slope? How would this process change? Oh, you're losing your Skittles. They're going everywhere. Any ideas? So I gave you 2 points here. What if I just give you a, not on this example, what if I just give you a point and a slope? What do we do differently? We don't have to find a slope. It's already done for us. So we have one less thing to do. Yes. Look at that. Beautiful. All right. Here's something to think about for those of you guys who don't like the fraction thing. You're trying to like write a standard form. If your slope ended up being a fraction, and we're trying to get standard form out of that, you could do, because this is an equation, you could say, I want to get rid of that denominator. So we take the entire equation, we multiply by whatever that value is, and bam, no more fractions. And then you're able to write it into standard form. So that's what's happening here on this one. You're getting rid of the 3, multiplying everything by 3. So this whole equation, and this, you're able to do this because it's an equation. You take that whole thing, multiply it by 3, and you get what's over there on the right. Now, you don't have to, although some people might, you don't have to distribute the 2/3 in. You can leave it out here and just get rid of it real quickly by doing this, multiply by 3. Then I can just leave that x minus 1 as it is in the parentheses there. And then you're able to rewrite it. So that's not in standard form yet. 2x minus 2. Move my x over here. Kick my 6 over to the right. And then I got to get rid of that negative 2 by dividing everything by negative 1. Yeah. Okay, hang on. We're gonna rock and roll here through this real quick. Yep. 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 Okay. How about this? Parallel. What do you remember? Parallel, perpendicular. What do we remember about those things? Good job. Which ones have the same slope? Parallel ones do. And what are perpendiculars? They have opposite reciprocal slopes. All right. So all we need to do if we're supposed to write an equation that's parallel or perpendicular to one line is to find the slope of that line, and then either make it the same for the other equation that we're looking for, or make it the opposite reciprocal. All right, so in that first one there, where we're going to go through 0.57, and we're going to be parallel to y equal 1/2 x plus 11. How smart the board is going to be today. 1/2 x plus 11. Now that's pretty good to me. If I was a smart board, I would recognize it as being 1/2 x plus 11. But you're not a smart board, are you? No. Oh, you are today. You are a smart board today. Good, good, good. Let's see what it looks like. I'm off my grid. No worries, people. We have the technology to change that. So I need to go way out here, don't I? I need to go, man, keep going until I get to, oh, there we go. And then, how far are we going to go there? Okay, so there's my line. And then I'm supposed to go through 0.57. So where's 0.57? Right here. There it is, 0.57. Then I got to be parallel to that line. So now we got a visual of what it's supposed to look like, right? It's supposed to be looking something like that. So that's the line. That black line is the one we're trying to write the equation. And you know, if I didn't have the graph up here, I don't have to have the graph up here. But if I do, I can look at it and see, hey, can I figure out where I'm crossing the y-axis? It kind of looks like y-axis. I'm crossing at like a half point. Now, I don't want to guess where that is, so I'm not going to. What I'm going to use is I'm going to use the slope from this purple line. I'm going to use the point from this line that our black line is going through, because that's the one we're writing the equation for. And then we're going to write our equation in what the slope of y minus 6. All right, somebody tell me what it is. Quick, you don't need any work. You can look at it. What is it?
Like the equation.
Yeah, what's my equation? I'm going to...
y minus 7 equals 1/2 x minus 5.
Beautiful. Y minus minus 7 equals 1/2 to x minus 5. Now notice it said write the equation in point slope form. Done. Done. Okay, let's keep going because we want to practice going into slope intercept. Somebody take me to slope intercept. Where's it going to look? What's it going to look like? Oh, I got fractions. What are we going to do here? Okay, we're going to distribute. Bobby says we're going to distribute. So now this looks like y minus 7, 1/2 x minus 5 halves. Okay. Now what? Remember, there's only 2 steps. That's one of them. What's the second step? What? Add 7. Good. But do I want to add 7? Because I'm adding to a 5 halves. So really, what do I want to add? Not 7. What do I want to add to a 5 halves so that I get common denominator?
7 halves?
14 halves. Yeah, I am adding 7. So here's what I got. I got a negative 5 halves, and I am adding a 7. But if I'm working with fractions, I need that 7 to be a denominator of 2, which means a 14. So I'm adding 14 sevenths to the other side, or 14 halves to the other side. And then, now you're in slope intercept form. Y equals 1/2 x plus 9 halves. So there's slope intercept form. That was our point slope form. Let's go ahead and take it to standard because, just because. No reason, just because. So how are we going to take this thing to standard? Two steps. Step number 1. Get 2 things together. What do we like to get together?
You subtract the 1/2.
Very good. 1/2 x. You move the 1/2 x to the other side because x's and y's like to hang out. They like to hang out. Okay, but we're still not there at standard form yet because I don't like that negative 1/2 thing, and I don't like the 9 halves thing. What's that? Multiply by a, so my common denominator is a 2. I'm going to multiply that. And I'm going to multiply by a negative because I do not want that lead term to be negative. So this whole thing multiplies by a negative 2. Can't really see that, can you? Try that again. Multiplies by, oh, that's just humorous. Oh, man. Oh, man, what are we going to do? What's going on? That thing's freaking out. Okay. Right, try this again. So we're going to multiply by a negative 2. That makes this now an x minus 2y equaling negative 9. And now we are in standard form. So look at that. All of that. Writing from one to the next. Okay, how will that process change to go perpendicular? What's the only thing that's going to be different? I have to find a negative reciprocal slope. Which means, in that problem, my negative reciprocal of a 1/2 would be a negative 2. You guys know what you're doing. See, look at it. You know what you're doing. I don't even need to be up here. Why am I up here? I don't know. Graphing? We need some help with graphing. Joe, we get on graphing. Honestly, we need some help with graphing. Slope intercept form. Go through B, tell me where the slope is, and then follow it. Point slope form, start with the point, tell me where the slope is, go with it. Standard form, cover up x, find y. Put it on the y-axis. Cover up y, find x. Put it on the x-axis. Connect the 2 points. There is no slope on the first one. Okay, good. It is a 1. You're right. You do not see the number hanging out there in front of the parenthesis for the point slope form. It is a 1. If I could quickly start. So, starting, where am I going to start this one? Where am I going to start this graph? Ooh. I want to start it here. Can anyone tell me what those values are? Not negative 3. x1 is 1. What is my y? Negative 3. The opposites. So if you have an equation, take the opposite x and y values, there are your points that you start with. This is where I begin. So I'm going to start at 1, negative 3. 1, negative 3. There I go. And then simple as this. If my slope is 1, that means from that point, I go up 1 over 1, up 1 over, no, up and right. Don't always up or down. Right? Up if I have positive slope, down if I have negative slope, and you always go right. So positive slope, up, right. Negative slope, down, right. So I'm going to go up 1 over 1 for this. It's going to look like this. Here's my equation. Graph. So point slope to slope intercept. Same thing. Start at a point, go where my slope tells me to go. Standard form, we cover things up. Let's go check out standard, because this is the one probably most of us. Who would rather graph and slope intercept versus standard form or point slope? Anyone? Any takers? Most of us, yes? Yeah, you guys would rather graph and slope intercept, right? You could always change these equations into slope intercept form. You could do that, and then graph them. But why not learn to graph them in the forms that they're in? I don't know. Makes sense. Graphing standard form, you're going to find x, y intercept, and I refer to that as the cover-up method. What does that mean? Well, you want to find an x-intercept, you cover up the y. And when you're covering up, what you're doing is you're making it go to 0. So if I had 3x now equal to 12, that means x is equal to 4. That's my x-intercept. Ah. 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 And then if I did the same thing, I made x equal to 0. That means I'm finding a y-intercept. I get negative 4y is equal to 12. That means y is equal to negative 3. Right? Y equal to negative 3. Connect the dots. Now, tell me what you think. What might some mistakes be for people that are graphing in standard form doing this? It's actually a common error. Standard form graphing. Give me some ideas. What are people going to do? Going to do what? Okay. Come on. What's an easy thing to make a mistake on? Graphing standard form. Go ahead, Sam.
They accidentally use point 4 negative 3. Like,
Yes, exactly. That's what often happens, is you find the x-intercept, 4. You find the y-intercept, negative 3, and people put a point at 4, negative 3. Well, now where do you go? If you have this point at 4, negative 3, how do you know where your line is? So don't do that. That's a no-no. They are two separate points. When you find x equal 4, when you find that, it's on the x-axis. When you find y equal negative 3, it's a point on the y-axis. So now you have 2 points. All you need to draw a line is 2 points. Once I have my 2 points, I connect them, and I'm good to go. So I don't have to change anything in the slope intercept. I can just go with what I've got. There's my line. Easy. You don't change it. You don't have to change it. Yes, sometimes with point slope or standard form, when you cover up, you get a fraction. Well, now you're guesstimating where that is on the axis. You're just eyeballing it. If it's a 3/2, you go 1.5 over. Figure out where 1.5 is, draw your line. So don't freak out if you get these problems where I get standard form when I'm graphing on a fractional value. No big deal. All right, so we're going to wrap this thing up. Look, we're doing it really fast because this is all we're doing. Isn't that nice? Okay, let's see if we can do this one. Put it into some application here. Fishing rods. Any fisher people in here? Yeah? Oh, yeah? Okay. Fisher people. Cross-country ski boots. Anyone do that? Do you do cross-country too? No. How about snowshoeing? Anyone do any snowshoeing? No. Okay. Does anyone ever get outdoors? Well, great. Yes. You guys are just like exciting. Exciting group of people here. All right. See if we can figure this out. Hardest part. Mm-hmm. Oh, look at that. I even cheated. I was going to say the hardest part's coming up with the equation. Let's see if we can find it, though. Oh, wait, you can't see it because I don't have the... I think we're just doing part A. Maybe there's a part B. Let's see if there's a part B. Finding the retail price. You guys know what retail is? Bless you. Sneeze like you mean. So, does everyone understand the concept of retail? All right, so what's retail? So you own a store, and you buy an item, and you buy that item at your cost, what you pay. Retail is what you're going to sell for. Mm-hmm. So usually you're going to sell for more than what you buy. So that's it. All right, so pair up so you guys can do this one. So we've got selling is that number. Cost is this number. So I have cost selling for the fishing rod. I have cost and selling price for the ski boots. And again, the way the equation is given to you, this is equivalent to my y value, which is dependent, and this is equivalent to your x value, which is your control. So I know that it's set up coordinate-wise like this, where I have CR. And then from those 2 points, we use those to find my slope. And we have our change of y's, or our change of, in this case, r's, over change of costs. So 106. 2, and then we get 1824 over 20, which is 6 fifths. There's my slope. And then I'm going to plug them back in using one of those 2 points to come up with my equation. I don't have my equation yet. All I have is the slope. So I either use 6082 or I use 8106 and set up point slope. So we're going to use 6082. We're going to set up y minus 82 is equal to m times x minus 60. Distributing everything, we have 6 fifths x. Oh, are we? Oh, yeah, we're supposed to put it in slope intercept. And then 60 divided by 5 is 12, and 12 times 6 is 72. So I got rid of that other fraction there. Then move the 82 to the other side. We get 6 fifths x plus 10. Is that what you guys ended up with? Yes. So that would be r and c, huh? R would equal 6 fifths c plus 10. So there's the equation that I have for this particular comparison between these two items. Then we want to find out the retail price for a pair of shoes that cost 40. So again, this number here is a C value. We are looking for an R value in the problem. So I'm going to plug 40 in for my X, or my C, into that equation. So we have 48 plus 10. So who was it that had the $58? Who was it? Is that you, Alex? Nicely done. So it cost retail $58. That's a ripoff. What's the markup on that? You guys, what's the percentage increase? Can you figure that out? What is it? Huh? What would, okay, let's start out with this. What would a 100% markup look like? How much is it going to cost you as the consumer? $80. $80 if it's a 100% markup. Now we're almost at 60, so it's about a 75% markup. And that actually is probably, I would say, on the low side. It depends on the item. Some items are going to obviously be priced as a higher markup than others. But that's probably, maybe that's not on the low side. Maybe that's not. That's how you make money, right? If you're a store owner and you're going to have a profit eventually, you got to have a markup on the things that you produce. All right, any questions on that? No.